Welcome students. From today, we will start the chapter-wise discussion of this book. So, let's start chapter 1. Chapter 1 is quadratic equation with one variable. Now, what is quadratic equation? Any equations in the form of ax square plus bx plus c equal to 0 is the quadratic equation. Why it is a quadratic equation? Because the degree of this equation is 2. Means the maximum power of the variable in this equation is 2. Now, name the variable in this equation. The variable is x and its maximum power is 2. So, it is a quadratic equation of one variable. Now, the next term is polynomial. What is polynomial? Polynomial means the equation that has 1, 2 or many terms is called polynomials.
Now, the types of polynomials.
The equation that has only one term is called monomial. The equation that has only two terms is called binomial. The equation that has only three terms is called trinomial. And all these equations are called polynomials. Okay?
Now, it is clear to all that what is polynomial and what is quadratic equation. Now, we can start the exercise.
Exercise 1.1. The first sum is, which of the following polynomial is a quadratic polynomial? So, we have to identify the quadratic polynomial.
First part of question 1.
X square minus 7x plus 2. Now, it is a quadratic polynomial as the degree of this equation is 2. That is, 2 is the highest power of the variable. So, we can write in this way that the above polynomial is a quadratic polynomial as it is a second order polynomial, means quadratic polynomial equation in a single variable, means the highest power of the polynomial is 2. Now the next sum, 7x to the power 5 minus x into x plus 2 in bracket. So, if we remove the bracket, then we will get 7x to the power 5 minus x square minus 2x. That is, it is not a quadratic polynomial as the highest power of x is 5. So, it is not a quadratic polynomial. So, we can write that the above polynomial is not a quadratic polynomial as the highest power of the variable is 5. Now the next sum, 2x into x plus 5 in bracket plus 2. If we remove the bracket, we will get 2x square plus 10x plus 1. That is, it is a quadratic polynomial as the highest power of x is 2. So, we can write the above polynomial is a quadratic polynomial as it is a second order polynomial equation in a single variable. Okay. Now, the last sum of question number 1. 2x minus 1. It is not a quadratic polynomial as the highest power of the variable is 1, not 2. So, the above polynomial is not a quadratic polynomial as the highest power of the variable is 1. Okay. So, question number 1 is complete. Now, question number 2. Which of the following equation can be written in the form of ax square plus bx plus c equal to 0, where a, b, c are real numbers and a not equal to 0. Let us write it. So, we have to check that whether the equations given can be written in quadratic form or not. So, the first equation, x minus 1 plus 1 by x equal to 6. So, we can write this equation like this. X is the LCM. So, x square minus x plus 1 equal to 6. Now, we move this x from left to right. So, it will be x square minus x plus 1 equal to 6x. Now, move this 6x from right hand side to left hand side. So, it will be minus 6x. Now, the equation will be x square minus x minus 6x plus 1 equal to 0. That is x square minus 7x plus 1 equal to 0. So, this is the form of ax square plus bx plus c equal to 0. So, the above equation can be written in the form of ax square plus bx plus c equal to 0, where a equal to 1, that is not equal to 0. That is, the coefficient of x square is 1, not 0. So, we can say that this equation can be written in the form of quadratic form. Okay. Now, the next sum. The next equation is x plus 3 by x equal to x square. LCM is x. The equation will be x square plus 3 by x equal to x square. Now, move this x from left to right, then it will be x cube. So, the equation will be x square plus 3 equal to x cube. Now, move this part from left to right. So, it will be minus x square and minus 3. Here it is x cube minus x square minus 3 equal to 0. So, we can see that it is not the form of ax square plus bx plus c equal to 0, as the first term is x cube, not x square. Okay. The highest degree of this equation is 3, not 2. So, it is not a quadratic equation. So, we can write that the above equation cannot be written in the form of ax square plus bx plus c equal to 0. Okay. Now, subpart 3. X square minus 6 root over x plus 2 equal to 0. This implies x square minus 6 x to the power half. We can write it as root over means to the power half. Okay. Plus 2 equal to 0. Now, we can see that this equation doesn't match this form, as x to the power half is absent here. Okay. So, we can write that the above equation cannot be written in the form of this. Now, subpart 4. X minus 2 whole square equal to x square minus 4x plus 4. Now, we know that x minus 2 whole square is the form of a minus b whole square. So, we can write x square minus 2 into x, that is 2ab, plus 2 square, that is b square, equal to x square minus 4x plus 4. Now, moving all the term in one side, we will get x square minus x square minus 4x plus 4x. plus 4 minus 4 equal to 0. Okay. Now, we see that all the terms cancel each other. So, we can write this implies 0. It is not the form of ax square plus bx plus c. So, the above equation cannot be written in the form of ax square plus bx plus c equal to 0. Sum number 2 is complete. Now, sum number 3.
Let us determine the power of the variable in which the equation x to the power 6 minus x cube minus 2 equal to 0 will become a quadratic equation. So, we have to change this equation in a quadratic form by managing this power. Then, how will we do that? We can write x to the power 6 in this form, x cube whole square. Now, it is in the quadratic form. Let x cube equal to y. So, the modified form is y square minus y minus 2 equal to 0. This is a quadratic equation as the maximum power of the variable is 2. So, the answer is this equation is converted into a quadratic equation and its variable is y, that is x cube. Okay. Now, the next sum. Sum number 4. Let us determine the value of a for which the equation a minus 2 multiplied by x square plus 3x plus 5 equal to 0 will not be a quadratic equation. Means, it is clear that if a equal to 2, then 2 minus 2 is 0 and 0 multiplied by x square is also 0. So, this x squared term will vanish and the equation will no more a quadratic equation. So, we can say that we have to make this coefficient 0. For this, we can write a minus 2 equal to 0 as we have to make this coefficient 0. So, we write this a minus 2 equal to 0. Then a equal to 2. So, the value of a is 2. If we put 2 here, then the equation will no more a quadratic equation. Okay. Now, the next sum. If x divided by 4 minus x equal to 1 by 3x, where x not equal to 0, comma x not equal to 4 be expressed in the form of ax square plus bx plus c equal to 0, where a not equal to 0, then let us determine the coefficient of x. So, what we have to do? We have to change this equation in a quadratic equation. For doing this, first we have to perform cross multiplication. Then the equation will be 3x into x equal to 4 minus x. That is 3x square equal to 4 minus x. Now, change the side of this two term from right side to left side. Then it will be 3x square plus x minus 4 equal to 0. Therefore, we can express equation 1 as a quadratic equation, that is in the form of ax square plus bx plus c equal to 0. Now, we can see that the coefficient of x is 1. See, the coefficient of x is 1. Okay. Now, the third part of question 4. Let us express 3x square plus 7x plus 23 equal to x plus 4 multiply x plus 3 plus 2 in the form of a quadratic equation ax square plus bx plus c equal to 0, where a is not equal to 0. So again, we have to convert this equation in a quadratic equation. First, we have to perform this multiplication. We will get x square plus 3x plus 4x plus 12 plus 2. Now we are arranging all the terms in a proper manner. After that, we perform some calculations, and the final equation is 2x square plus 9 equal to 0. If we compare this equation with ax square plus bx plus c equal to 0, then we will see that here this second term is missing. So to introduce the second term, we can write the following equation in this form: 2x square plus 0 into x plus 9 equal to 0, which is in the form of ax square plus bx plus c equal to 0. Okay. Now this is the quadratic equation. Now part 4 of question 4. Let us express the equation x plus 2 whole cube equal to x into x square minus 1 in the form of ax square plus bx plus c equal to 0, where a is not equal to 0, and write the coefficient of x square, x and x to the power 0. Okay, first we convert this equation in a quadratic equation. For this, we have to perform some steps, like x plus 2 whole cube means x cube plus 3 into x square into 2 plus 3 into x into 2 square plus 2 cube equal to, multiply this two term, we will get x cube minus x. Now arranging all these terms in a proper manner, we will get 6x square plus 12x plus 8 plus x equal to 0. That is 6x square plus 13x plus 8 equal to 0. Now we have to find the coefficient of x square, x and x to the power 0. For this, we can write this equation in this manner: 6x square plus 13x plus 8 into x to the power 0. As we know that x to the power 0 is 1. So, we can write this equal to 0. Now, the coefficient of x square is 6, the coefficient of x is 13 and the coefficient of x to the power 0 is 8. Here, question number 4 is complete. Now, question number 5. Sum number 5. Let us construct the quadratic equations in one variable from the following statements. So, we have to make the quadratic equations from the following statements. First part of question 5. Divide 42 into two parts such that one part is equal to the square of the other part. So, in this statement, one part is dependent on the other part. So, let the independent part, means the other part, be x. We have to assume the independent part as x. Therefore, one part equal to x square means the dependent part equal to x square, as given in the statement that one part is the square of the other. So, one part is x square. Now, according to the question, we can say that summation of these two quantity is equal to 42, as given in the statement that divide 42 into two parts. So, x plus x square equal to 42. Now,
move this 42 from right to left. It will change the sign. So the required quadratic equation is x square plus x minus 42 equal to 0. Therefore, the required quadratic equation is x square plus x minus 42 equal to 0. Okay? First part complete. Now, second part of question 5. The product of two consecutive positive odd numbers is 143. So, we have to assume two consecutive odd number such that their product will be 143. So, let one consecutive odd number is x. We have to assume it. Therefore, the other one is x plus 2 as they are consecutive odd numbers. Okay. Like if 3 is the first odd number, then 3 plus 2 means 5 is the next consecutive odd number. So, we have to add 2 here to get the next consecutive odd number. So, the next consecutive odd number is x plus 2. Now, according to the question, the product of these two consecutive odd number is 143. So, x multiply x plus 2 equal to 143. Now, remove this bracket and multiply this x plus 2 by x. We will get x square plus 2x equal to 143. Now, move this 143 from right to left. It will change its sign. So, the final quadratic equation is x square plus 2x minus 143 equal to 0. The required quadratic equation is x square plus 2x minus 143 equal to 0. Second part is complete. Now the third part. The sum of the squares of two consecutive numbers is 313. So again we have to assume two consecutive number. Let the two consecutive number is x and x plus 1. Two consecutive number. Now according to the question, summation of the squares is equal to 313. So we will write x square plus x plus 1 whole square equal to 313. Now remove this bracket. This is a plus b whole square formula. So we can write x square plus 2x plus 1 as it is a square plus 2ab plus b square. Now we will get x square plus x square plus 2x plus 1 equal to 313. X square plus x square means 2x square plus 2x plus 1 equal to 313. Now move this 313 from right to left. It will change the sign. So the equation will be 2x square plus 2x plus 1 minus 313 equal to 0. Now plus 1 and minus 313, it will give minus 312. Now the equation will be 2x square plus 2x minus 312 equal to 0. Now we divide all the terms by 2 as 2 is the common factor. After dividing by 2, the equation will be x square plus x minus 156 equal to 0. This is the required quadratic equation. Therefore, the required quadratic equation is 2x square plus 2x minus 312 equal to 0 or x square plus x plus 156 equal to 0. Sorry, here is a silly mistake. This will be minus 156, not plus. Okay, third part is complete. So question 5 is complete. Now question 6. Let us construct the quadratic equation in one variable from the following statement. So some statements are given and we have to make the quadratic equation based on this following statements. First statement is given: the length of the diagonal of a rectangular area is 15 meter and the length exceeds its breadth by 3 meter. So the independent quantity is breadth and length is 3 meter more than breadth. So let the breadth be x meter. We have to assume the independent quantity, that is breadth, as x meter. Therefore, the length is x plus 3 meter. It is already given that length is 3 meter more. Now, we know that breadth square plus length square equal to diagonal square. We all know that this is a common formula in rectangle. So, we just apply that formula to solve x. X square plus x plus 3 whole square equal to 15 square. Now open this bracket. It is a plus b whole square formula and the whole equation will be x square plus a square means x square plus 2ab means 2 into 3 into x, that is 6x, plus 3 square, that is 9, equal to 15 square. X square plus x square, that is 2x square, plus 6x plus 9 equal to 15 square means 225. Next, 2x square plus 6x equal to, we move this 9 from left to right, it will change its sign, so it will be 225 minus 9. Now 2x square plus 6x equal to 216. Next, 2x square plus 6x, again side changing. So plus 216 will move from right to left and it will be minus 216 equal to 0. These are all even numbers. So 2 is common factor of each term. We just remove this 2 and the equation will be x square plus 3x minus 108 equal to 0 divided by 2 means 0. So the final equation is x square plus 3x minus 108 equal to 0. Therefore, the required quadratic equation is x square plus 3x minus 108 equal to 0. Now next statement. One person bought some sugar at rupees 80. If he would get 4 kg more sugar with that money, then the price of 1 kg of sugar would be less by rupee 1. So, the sum is about price of the sugar. The main concept is a person, first he bought some sugar at rupees 80. But if he would get 4 kg more sugar with that money, then the price of the sugar would be less by 1 rupee per kg. Okay. So what is the equation? Let the person bought x kg of sugar in 80 rupees. So price of x kg sugar is rupees 80. Therefore price of 1 kg of sugar is, we have to divide this quantity. So rupees 80 divided by x, that is rupees 80 by x. It is the price of 1 kg of sugar. But if we get x plus 4 kg sugar, then the price of 1 kg of sugar will be The price of x plus 4 kg sugar is rupees 80. As mentioned in the problem, that if he would get 4 kg more sugar with that money, means we can say that the cost of x plus 4 kg sugar is now rupees 80. So the cost of 1 kg of sugar is rupees 80 divided by x plus 4. Now, according to the question, difference of these two price is rupee 1. That is what we have written. According to the question, 80 by x minus 80 divided by x plus 4 equal to 1. Now, x plus 4 is the LCM, and in numerator we will get x plus 4 into 80 minus 80x equal to 1. Now, after simplifying it, we will get 80x plus 320 minus 80x divided by x square plus 4x equal to 1. Now, plus 80x and minus 80x will be cancelled. Therefore, 320 equal to, we just perform the cross multiplication here. So, 320 equal to x square plus 4x. Now, after arranging this equation, we will get the final quadratic equation, that is x square plus 4x minus 320 equal to 0. Therefore, the required quadratic equation is x square plus 4x minus 320 equal to 0.
Now the third part. The distance between two stations is 300 km. A train went to second from first station with uniform velocity. If the velocity of the train could be 5 km per hour more, then the time taken by the train to reach the second station would be lesser by 2 hours. So, the distance between the two stations is 300 km. At first, the velocity is x km per hour. Then the time taken to reach the second station is 300 by x hours by unitary method. That is, to cover x kilometer, we need 1 hour. To cover 1 kilometer, we need 1 by x hour. And to cover 300 kilometer, we need 1 by x into 300. That is 300 by x hours. Okay. Now, if the velocity will increase by 5 km per hour, then it will be x plus 5 km per hour. Then the time taken to reach the second station is 300 by x plus 5 hours by unitary method. So, according to the question, we can say that difference between these two time is 2 hours as mentioned in the problem. So, 300 by x minus 300 by x plus 5 equal to 2. LCM is x into x plus 5, and in numerator we will get 300 into x plus 5 minus 300x. Now the LCM is x into x plus 5, and in numerator we will get 300 into x plus 5 minus 300x equal to 2. This implies 300x plus 1500 minus 300x divided by x into x plus 5 equal to 2. Now we cancel this plus 300x and minus 300x. After that, we will get 1500 divided by x into x plus 5 equal to 2. Then cross multiplication is used. After that, we will get 1500 equal to 2x into x plus 5. Next, we remove this bracket and multiply it by 2x. This implies 1500 equal to 2x square plus 10x. After arranging all the term in one side, we will get 2x square plus 10x minus 1500 equal to 0. Now, here 2 is the common factor of all these even numbers. So, we remove 2 as common factor, and finally we will get x square plus 5x minus 720 equal to 0. This is the required quadratic equation. Okay. Now the next statement. A clock seller sold a clock by purchasing it at rupees 336. The amount of his profit percent is as much as the amount with which he bought the clock. So, the sell price of the clock is this. It is given. Let the cost price of the clock is rupees X. We have to assume this quantity. Now, the profit percent is also rupees X as given in the problem, that the profit percent is as much as the amount with which he bought the clock. So, the cost price and the profit percent is same. Now, profit equal to sell price minus cost price, that is 336 minus X. Now, according to the question, we can say that profit divided by CP into 100 equal to profit percent, means 336 minus X divided by X into 100 equal to X. We get this quantity by using profit percent formula, that is profit divided by cost price into 100, and this is the profit percent amount which is given. So, according to the question, we can say that this expression is equal to X. Now, from this we can write 336 minus X into 100 equal to X square. Next, remove this bracket. After multiplying by 100, we will get 33,600 minus 100x equal to x square. Now arrange all the term in one side and we will get the final equation, that is x square plus 100x minus 33,600 is equal to 0. So the required quadratic equation is x square plus 100x minus 33,600 equal to 0. Now the next sum. If the velocity of the stream is 2 km per hour, then the total time taken by Ratan Majhi to cover 21 kilometers in downstream and the same distance in upstream is 10 hours. So, first we have to assume the velocity of the still water. It is x kilometer per hour. We assume this quantity. Now, the velocity of the stream is 2 km per hour. It is given. So, the downstream velocity is x plus 2 km per hour. We know that. And the upstream velocity is x minus 2 km per hour. We know that. Now, the time taken to cover the distance in downstream, we use unitary method here, that is x plus 2 km is covered in 1 hour, then 1 km is covered in 1 by x plus 2 hour, and 21 km is covered in 1 by x plus 2 into 21 hour, that is 21 divided by x plus 2 hour. Similarly, in upstream, x minus 2 km is covered in 1 hour, 1 km is covered in 1 by x minus 2 hour, and 21 km is covered in 1 by x minus 2 into 21 hour. That is 21 divided by x minus 2 hour. Now, according to the question, we can say that the summation of these two time is 10 hours. Okay. Now, if we simplify this equation, then we will get the quadratic equation. 5x square minus 21x minus 20 equal to 0. This is the required quadratic equation. Okay. Now subpart 6. The time taken to clean out garden by Majid is 3 hours more than Mahim. Both of them together can complete the work in 2 hours. So, first we have to assume that Mahim takes x hours to complete the whole work. So, Majid takes 3 hours more, means x plus 3 hours to complete the whole work. Let the whole work equal to one part. In the sum, our first target is to calculate 1 hour work of Mahim and 1 hour work of Majid. So, in x hour, Majid can complete one part of the work, that is the whole work, and in 1 hour, he can complete 1 by x part of the work. So, this is Mahim's 1 hour work. Similarly, in x plus 3 hours, Majid can complete one part of the work, and in 1 hour, Majid can complete 1 by x plus 3 part of the work. So, this is Majid's 1 hour work. Now, if we add this to quantity, we will get 1 hour work of both when they are working together. So, in 1 hour, both are doing this plus this part of the work. We simplify this and we will get 2x plus 3 divided by x into x plus 3 part of the work. Now, in 2 hours, they will do this quantity into 2 part of the work. Okay. Now, according to the question, this is the whole part. As in the problem, it is given that both of them together complete the work in 2 hours. So, their 2 hour combined work is this. So, this is the whole part. So, according to the question, this quantity is equal to 1. That is whole part. Now, simplify this. We will get the final quadratic equation. That is x square minus x minus 6 equal to 0. Okay. Now, subpart 7. The unit digit of a 2-digit number exceeds its 10th digit by 6. And the product of 2 digits is less than the number by 12. So, first we have to assume the 10th place digit as x. Let the 10th place digit is x. Therefore, the unit place digit is x plus 6. It is 6 more than the 10th place digit. So, it is x plus 6. So, the 2-digit number is 10 into x plus 6. Means this is the 10th place digit. So, when we create a number, we have to multiply this digit by 10 and then add the unit place digit. Okay. So, 10x plus x plus 6. That is 11x plus 6. This is the whole number. Okay. Again, x into x plus 6 means product of 10th place and unit place digit is 12 less than the number. It is given in the problem that the product of 2 digit is less than the number by 12. So, if we multiply this 2 digit, then the product is 12 less than the original number. Okay. So, according to the question, we can write this. X into x plus 6 equal to 11x plus 6, that is the original number, minus 12. Now simplify it, we will get the final quadratic equation. X square minus 5x plus 6 equal to 0. Okay? This is the required quadratic equation. Now subpart 8. There is a road of equal width around the rectangular playground. In the outside of it, having the length 45 meter and breadth 40 meter, and the area of the road is 450 square meter. So first we have to assume the width of the road as x meter. Let the equal width of the road is x meter, length of the ground is 45 meter, and breadth of the ground is 40 meter. It is given. This is the diagram. This is the ground. This portion is the road. Therefore, the area of the ground is length into breadth, that is 1800 square meter. Now, the length of the ground including road is 45 plus x. And similarly, the breadth of the ground including road is 40 plus x. Okay? So, the area of the ground including road is this length into this breadth. Means 45 plus 2x into 40 plus 2x square meter. After multiplying these two quantity, we will get 1800 plus 170x plus 4x square meter. This is the area of the ground including road, and area of the ground excluding road is 1800 square meter. So, if we subtract these two quantity, then we will get the area of the road, okay, which is 450 square meter as given in the problem. So, according to the question, area of the ground including road minus area of the ground excluding road is equal to 450, which is the area of the road. Now simplify this, we will get 2x square plus 85x minus 225 equal to 0. This is our required quadratic equation. Okay? So subpart 8 is complete, and also exercise 1.1. In the next video, we will start exercise 1.2. Bye.